All right, welcome everybody to the big three kinematics equations. So, as we are getting into harder physics problems or harder kinematics problems, we will need to use different formulas. And the reason is because if we look at this formula right here, this is the velocity formula. Don't have my vector symbols there. If we look at this, this only gives us average velocity. Average velocity. Also, you might see on your formula sheet this formula. This also gives us average velocity. V final plus V initial divided by 2. This is also an average velocity formula. But anytime there is acceleration, we can't use average velocity, which means we can't use those formulas. And that's because we have V final and V initial, and we don't know if we're accelerating consistently. So we can't use this formula here. It doesn't work if there's an acceleration. It only is average velocity. It doesn't deal with V final, V initial. So in this unit, we use values, and I mean in the whole course, we're going to use these values. We use final velocity, initial velocity, we use acceleration, we use displacement, we use time. So there's a few different values that we're dealing with, and each of the big three equations has a combination of those values, but also excludes some of them so that we don't have to know them. So I'll show you what I mean by that. So the first one is VF is equal to V naught plus AT. I'll change that to VI. We'll try to keep our notation consistent. So in this formula, we know VF, or it includes, sorry, VF, VI, A, and T. Maybe I'll just write includes, and does not include displacement. So you notice that if you don't know the displacement, you have a formula you can still work with. And that kind of is how this whole thing goes. So this equation does not include displacement, so you don't need to know it in order to use that equation. The next one is distance or displacement is equal to VI multiplied by T plus 1/2 AT squared. So you can see that this one includes displacement, VI, time, and acceleration, but does not include the final. So you don't need to know the final velocity in order to use that equation. And the last one is V final squared is equal to V initial squared plus 2AD. So this one includes V final, V initial, acceleration, and distance, but it does not include time. So they all have a different combination of the values that we are solving for. And it's up to you to choose which one you need to use. And this is why making that list of knowns and unknowns is really going to help, because it's going to show you what formulas you have at your disposal or which formulas you can use. So you don't have to memorize these. These are all on your formula sheet, but you do need to know how to use them. Excuse me. So let's do a practice problem. A truck is traveling at 16 meters per second when it is passed by a plane. It immediately accelerates at 18 meters per second squared for 4.25 seconds. What final velocity does it reach, and how far does it travel in this time? All right, so let's start by, I'm going to just zoom out a little bit. Let's start by writing down our knowns and unknowns. So we know that the truck is initially traveling at 16 meters per second. So that's probably our V initial, 16 meters per second. It accelerates at 18 meters per second squared for 4.25 seconds. Time is 4.25 seconds. what final velocity does it reach, and how far does it travel in this time. So we need to find VF, and we need to find D. So let's start by finding the final velocity. Well, we know that we have these three, and I'm looking for this. So I need to find an equation that has velocity initial, acceleration time, and velocity final. And if you look, I'm just going to scroll back up. This equation right here has VF, VI, A, and T, which we want. So VF is equal to VI plus AT. We don't know the displacement, so we can't use either of the other two because this one, number 3 has displacement, number 2 has displacement as well. So let's plug in what we know. We don't even have to rearrange this. That's the best part. We don't have to do any formula manipulation because V final is already isolated. So 16 meters per second plus 18 meters per second squared multiplied by 4.25 seconds. And our final velocity, if we calculate all of that, will become 92.5 meters per second. That's incredibly fast, but it's a made-up physics problem, so it doesn't really matter. Okay, now we know V final. We can use this if we want to. So here's another thing when you're doing these equations that, or these questions, sorry, that build on each other. So here it says find velocity, find the final velocity and how far it travels. If you can find, so now that we're trying to find distance, if I can find distance without using the V final, that's going to be ideal. And the reason is because if I made a mistake calculating my final velocity, and then I use that number in calculating my distance or my displacement, then I'm just gonna, no matter how well I do it, I'm going to get it wrong because I'm using a wrong V final. So if you can get away with not using V final in the next calculation, that's always the best choice. You might not have that option all the time, but if you can, you should do that. So we have VI, we have A, and we have T, and we're looking for displacement. So if we have VI, T, and A, if we scroll up here or look at our formula sheet, you can see that we can use formula 2 because we're looking for displacement. It has VI, T, A, and T in it. So I'm going to use, oh, there we go. Don't want to get too colorful. D is equal to VI multiplied by T plus 1/2 AT squared. I don't even have to do any isolation, which is a bonus. D is already isolated. So now I have 16 meters per second multiplied by 4.25 seconds plus 1/2 times the acceleration, 18 meters per second squared, multiplied by the time squared, 4.25 seconds squared. Don't forget that squared. That's actually really common. That's a really common mistake, but I mean, everyone seems to forget that T is squared. All right, so we can do this in 2 steps if we want. 16 multiplied by 4.25 is going to give us 68. That's not right. This answer key is not right. Well, I mean, they're probably using sig figs. I'll just do it on my own because why the heck not? Oh, it is right. Huh. My brain is not working very well today. 68 plus all of this stuff here. Make sure we use our bed mass. So we're doing the exponent is only acting on the 4.25, and we get 162.6. And when we add those together, we get 230.6, and that is meters. There we go. So again, when you're solving problems, make a list of your knowns and unknowns. that is going to be the easiest way for you to choose the formula, manipulate the formula, and solve the problem. Cool. Thank you for watching.